How do Java debuggers work under the hood with JVMTI? Imagine trying to fix a complex machine without knowing how its internal parts work. That's what debugging Java applications can feel like without understanding what happens behind the scenes. When you use a debugger to find bugs in Java code, it's not just stopping and starting the program. It's interacting deeply with the Java virtual machine, or JVM, which runs your code. The secret tool that makes this possible is called the Java Virtual Machine Tool Interface, or JVMTI. JVMTI is a native programming interface, meaning it is written in a language like C or C++ and runs alongside the JVM inside the same process. It acts as a bridge, giving debugging tools the ability to peek into the JVM's internal workings. When you set a breakpoint or step through code, your debugger communicates with JVMTI to tell the JVM what to do. JVMTI then handles these requests by listening for specific events that happen during program execution. These events include when a method starts or finishes, when classes are loaded or unloaded, when threads begin or end, and even when garbage collection occurs. When any of these events happen, JVMTI sends notifications to the debugger agent. The agent can then decide to pause the program, gather data, or change the program state. This event-driven system allows debugging to happen smoothly and efficiently, without slowing down the application too much. Because JVMTI is tightly integrated with the JVM, it can access low-level information directly from the runtime. This means it can inspect local variables, monitor thread activity, and even control thread execution. This direct access is what makes language-specific debugging in Java so powerful. It allows tools to perform advanced tasks like conditional breakpoints, thread analysis, and memory inspection. The communication between the debugger front-end and JVMTI happens through the Java Debug Wire Protocol, or JDWP. JDWP acts as a messaging layer, letting the debugger send commands and receive responses from the JVM. This setup means you can run your debugger locally or remotely, and JVMTI will handle the detailed interactions with the JVM. Understanding how JVMTI works helps you see how Java debuggers can do so much more than just pause and resume code. They can inspect the internal state of the JVM, control execution at a very detailed level, and gather profiling data to optimize performance. This foundation is what makes Java debugging precise, flexible, and effective for fixing even the most complex bugs.